Hi guys, this is Mrs. Econ. In this video, you are going to learn about exponents and the 7 exponent laws. Before we go ahead into the exponent laws, I'm just going to explain it to you how really exponent works. Okay, so if you look at right here, the example, exponents are basically repeated multiplication. Okay, so now you have two numbers, one number is at the bottom and there's a small number at the top. The number at the bottom is called the base. The number at the top is called the exponent. Basically, it means the base gets repeated whatever your exponent is. So in this case, it's 2 to the power 3, means your 2 will get repeated 3 times. It's 2 times 2 times 2. And then you just multiply it, simplify it, answer will be 8. Okay. So now let me explain it to you some the 7 laws of exponents, and I will also give you some examples. All right, rule number 1. Okay, so rule number 1 is the zero exponent law. Basically, it says anything to the power of a 0 is 1. So anything raised to the power 0, it's a 1. So 2 to the power 0 is 1. It's anything, any base that has a 0 exponent, answer will be 1. So it's 100 to the power 0 is 1. Million to the power 0 is 1. Anything to the power 0, it will be always a 1. And there's an example right here. And I wrote in kind of complicated expression here. I have seen sometimes what students do. They go ahead and start solving that. Okay. But you don't need to simplify the expression right here. You don't need to. Okay. Because even though you do, at the very end, your answer will be 1. Okay. Now, if we look at here, we have an exponent 0. So anything to the power 0, it's a 1. You don't need to simplify that. So again, doesn't matter what your expression is, as long as the power is a 0, the whole thing will be 1. Why it's 1, I'm going to explain it to you in one of those the laws, and then so that you know where that 1 is coming from. Alright, so here we are going to look at rule number 2. It's the negative exponent law. Negative exponent law, basically it says anything, a base that has a negative exponent, you write that as 1 over a. The negative exponent in the denominator, it just becomes a positive exponent. Okay, so every time you see a base with a negative exponent, you just put a 1 over a. So let's say 2 to the power negative 1. That will be 1 over 2. I'm just going to give you an example here. I hope that makes sense to you. So let's look into some numbers. I will start with the 10 to the power 3. What is 10 to the power 3? It's 1000. Okay. And what's a 10 to the power 2? That is 100. So I hope you haven't noticed. So in order to come from here to here, what are we basically doing? We're basically dividing by 10, right? Then let's look at 10 to the power 1. What's that? 10. Again, we divided the previous number by 10. Now 10 to the power 0, based on the exponent law. Anything to the power 0, it's a 1. Okay, so now let's see if I need to write 10 to the power negative 1. How do I write that? That will become 1 over 10. It's literally same thing, but it's just a way to write it down. Our calculators, we only have an option putting the numbers in a positive form. Okay, so it's 2 to the power negative 1. It's same as saying it's a half. Okay, so that's how it really works out. And let me give you some examples here. Okay, so let's say it's 7 to the power negative 2. 1 over 7 to the power 2, we simplify, will be 1 over 49. Let's say 4 to the power negative 1. How do I write that in positive form? 1 over 4. So this is basically a quarter. Which number makes more sense to you? writing a quarter this way, or you let's say you're asking a quarter from someone, you want to say give me a quarter, or you want to say give me 4 to the power -1. Okay, so this number makes more sense, a quarter of something, not 4 to the power -1. So in math, we just prefer to write numbers in a positive form. That's why we have laws and rules, so that we can all follow the same rules to simplify the expressions. Okay, I hope that makes sense. Okay, let's look into now rule number 3. Okay, that's a product law. The product law, it says when you have two bases, they are same. You keep the base as it is, you just add their exponents. That will be a plus b. And there's an example done halfway. I'll just finish it off here. You have a same base, and then what you do, you keep the base as it is, you add the exponents. 3 plus 2, it's 2 to the power 5. And what's a 2 to the power 5? It's 2 times 2 times 2 times 2 times 2. That's what 2 times 4. 8, 16, 32. So your answer is 32. It's not a 10. It's not 2 times 5 is a 10. You just repeat it. How many times? Whatever your exponent is, this number of times it gets repeated. Okay. Let's do another example. So 3 to the power 2 and 3 to the power 1. Okay. We have a same base. We'll keep the base as it is and add the exponents. 2 plus 1 is 3. 3 to the power 3 is 27. Okay, so it's easier to use the laws to simplify the expression. Let's say you don't want to. Let's do another example here. So I'm running out of space. Okay, so let's say it's 2 to the power 10, and that is 2 to the power 100. Okay, if you want to write that in simple form, you're not going to write it 10 times here and then 200 times here. Okay, it's just like a crazy process writing 200 times. That's why we have a law to write the numbers in simple form. Okay, that will be 2 to the power, based on the law, you keep the base as it is, you add the exponent. So what is 10 plus 100? It will be 2 to the power 110. I just randomly gave you an example. This number makes more sense than writing 2 with 110 zeros. Okay. Alright, so we're going to move on to rule number 5. It's called the quotient law, or the division. Okay, so in this one, let's say you have x to the power a divided by x to the power b. Okay, so the common thing you have to notice here, we have a same base. When we have a same base, we keep the base as it is. In a quotient law, we are going to subtract the exponents. Okay, it will be a minus b. Let me do some examples, show you why do we really subtract it. Okay, so let's say we have 2 to the power 3, and then we have a 2 to the power 2. Okay, I'll do one using the rule, then one I will do it in a long way. So based on a rule, what does the rule say? When you have a same base, you keep the base as it is, and then you subtract the exponents. That is 3 and 2. It's going to be 3 minus 2. So it will be 2 to the power 1. Answer is a 2. Okay, so let's do it in a long way. Okay, 2 to the power 3 basically is 2 times 2 times 2 divided by 2 to the power 2. So 2 times at the bottom. So now I can cancel it. 2 can cancel with this one. This can cancel with that one. What are you left with? Just 1, 2. See, we have the same answer. The laws are more handy when you have big numbers. So let's say, we'll do another example here. Let's say you have 2 to the power 10 divided by 2 to the power 8. Well, you're not going to write it down 10 times. You can, but why would you waste your time, right? Where you can use the laws to help you out to simplify the questions faster. Okay, so based on the law, it says when you have the same base, do we have the same base? Yes. What we do, we keep the base as it is. We subtract the exponent. So it's a 10 minus 8. That is 2 to the power 2. Answer is 4. Instead of writing 2 10 times at the top and then writing 2 8 times at the bottom, canceling that out, and then you're going to left with 2 2's, which is 2 times 2 is 4. See, we just did the same thing in one line. Okay, that's a quotient law. I'm just going to go back to the zero exponent law as well here. So let's do one example very similar to the zero exponent. So let's say you have 2 to the power 1 divided by 2 to the power 1. And the quotient law says when you have a same base, you keep the base as it is. We have a same base, right? So that is 2. Keep the base as it is. 1 minus 1 is a 0. What's the 2 to the power 0? Is 1. Let's say we're not using the quotient law here and we are doing it a long way. So I'll erase this one. 2 to the power 1 is what? 2. That's also 2. 2 cancels out. What are we left with? 1. That's where that 1 is coming from. So anything to the power 0, because you have the same numbers at the top and same numbers at the bottom, they just cancel out. And then we left with just 1. Alright, power raised to a power. Okay, so let's say you have a to the power m, and then there is something written in that form. Anything written in that form, a number that has a power raised to a power. See, you have 2 exponents. That's what it's called, a power raised to a power. Then what you do, you keep that and then you multiply their powers. Okay, so I'll just show that to you now. Let's say you have 2 to the power 4 and then there is a 5 outside. This is power raised to a power. That's also exponent. That's an exponent too. These two are exponents. So based on a power raised to a power law, every time you have something like that, you just multiply the exponents. So we'll do 2 to the power 4 times 5. It's 20, which is that's your number. Okay. Okay, so your answer is 1,048,576. So let's say you're trying to do it in a long way. This height is going to look like it. Based on the exponent laws, it's your base gets repeated this number of times here. So that will be 2 times 2 times 2 times 2. And then we have another exponent outside. Okay. What you can do, you can simplify that, which is going to be 16 to the power 5. And then your 16 is going to get repeated 5 times. It's going to be 16 times 16 times 16 times 16 times 16. So 16 5 times. Answer is the same, but look at it, it's just a bit more complicated. Okay, there's 1,048,576. It's the same answer as I said it before, but I prefer this way. It's simple, concise, easy to see, okay, and easy to simplify as well. Okay. Alright, so we have 2 more rules left. Power of a product. Okay, so in this rule it says, let's say you have two different bases inside and there is a power. Let's say it's a P. Power of a product, whatever is outside, it gets repeated. It's a part of both of them. It's m to the power P is n to the power P. For example, you have a 5, a to the power 2, and then there is a 3 outside. Okay? That 3 is a part of everything inside. There are multiple ways to do it. So that basically means it's 5 to the power 3. Then you have a to the power 2. Then there is a 3 here. Okay. This is going to be 5 to the power 3 is 125. And then power raised to power. I hope you still remember the law here. It's going to be when you are raising power to power, you just simply multiplying them. This is going to be a to the power 6. Okay, last law left is called the power of a quotient. Okay, let's say you have something written as a over b to the power n. This power belongs to both numbers inside a fraction. That basically means a to the power n divided by b to the power n. I'll do one example here. Let's say you have 3 to the power 2, and then there's a power, we'll keep it simple, 2. There are 2 ways to do it. You can do 3 over 2 times 3 over 2, or you can do 3 to the power 2 divided by 2 to the power 2. That is going to be 9 over 4. Okay. Or in multiple ways, as long as you know how to apply the laws and rules, your question, your simplifications will be in a lesser steps. You could have also used here 3 over 2 times 3 over 2. Okay. And it will be 9 over 4. This is all for now. I hope you guys learned something in this video. If you have any questions, you can put that in the comment section. If you're concerned, you can also put that in the comment section as well. One thing I just want to say about exponent laws, I don't think so you are required to memorize the law. Okay, using this law, simplify this question. Using this law, simplify this question. It's just a way of simplifying the questions. There is whatever type of question you see, you can apply whichever law you think you can use it here. See, like here right now for this question, even though I explained the power of a quotient basically says whatever you power it gets distributed to the denominator and to the numerator. But here when I simplify, here I use the product rule. Product rule is whatever is inside gets repeated number of times your exponent is. So I just took the fraction and multiplied that fraction twice. Okay, so just a practice. More you practice, the better you get. I guarantee more you practice, your laws, your rules will start occurring to you naturally. You don't need to memorize. All right, bye bye.